Okay guys, so today we're going to get into multiplying and dividing radicals. Okay, so if you remember last week, the steps for adding radicals and subtracting radicals was to simplify first to see if the radicals are the same and then combine like terms. Okay, it's a little different with multiplying and dividing because for multiplying and dividing, the two radicals do not need to be the same to multiply them. Okay, so since they don't need to be the same, we don't need to simplify them first to see if they're the same. So step one to multiplying radicals is just going to be to multiply. Now again, you can multiply outsides. So that means anything on the outside of the radicals and insides with insides, okay? And you'll see what I mean as we do it. You're gonna multiply the outsides of the rads, you're gonna multiply the insides of the rads. And then what you're gonna do is simplify if necessary. You might not even have to simplify, okay? So first we multiply, then we simplify. So still two steps, but we're gonna just switch up that order. Okay, so here's what I mean. So this one has a number on the inside of the radical, a number on the inside. So you can multiply numbers on the inside with numbers on the inside. So here, if I multiply those numbers, I get 18, but it still would be in a radical. Okay, so my in-between answer would be radical 18, and that would always get you half credit because you've done the multiplication. However, rad 18 can still be simplified. So if we're still rocking, again, when we simplify numbers, we are still thinking about our list, right? So again, remember our list is square root of 4, square root of 9, square root of 16, square root of 25, right? So we have our list of perfect squares that we keep looking back to, right? 49, 64, 81, 100, you know, we could use this list. So 18 can be broken down into one of these numbers on the list, 9 and 2, right? So remember, we're just gonna break 18 back into 9 times 2. The square root of 9 is 3, right? Remember, we simplify our perfect. Final answer, 3 rad 2. Okay, so that's it. So you're going to multiply and then check to see if you can simplify. So here, again, we're allowed to multiply these two numbers because they're both under radicals. So here I get square root of 100. 5 times 20 is 100. Again, 100 can be simplified. What you will notice, 100 is one of our numbers on the list. So that means it's a perfect square. Again, if you forget what its square roots to be, just use your calculator and type in the square root of 100. Right? And we get 10. So this final answer is 10. Okay? Now, when you get to number 3, you will notice number 3 also has these numbers on the outside of the radical. Okay, that's what I mean up here on the instructions. Any numbers on the outside can get multiplied. So this 2 and the 3 can be multiplied to a 6. The numbers on the inside can be multiplied. But remember, if they're on the inside, the result is still inside a radical. So 5 times 10 is 50. So here I have 6 rad 50. Again, I am not done because 50 is something that can be broken down. So remember, if there is a number on the outside, we just bring it down with multiplication, right? 50 can be broken up into 25 times 2. 25 can be simplified to 5. So I end up with 6 times 5 times 2, rad 2. Final answer, 30 rad 2. Okay. Again, number 4 is very similar. So we have outsides with outsides. So -4 times -5 is 20. Again, you could use your calculator. Now I'm multiplying a rad times a rad, so I'm still in a rad. And what I get is 2 times 3 is 6. Okay? Now again, I look to see, can I break down rad 6? And if you think of things that multiply to be 6, there's only 6 and 1 or 2 and 3. None of those are on my list. So actually this one, I am done once I have multiplied. Okay? Now, what you might also see in this section is squaring. And the reason why you might see squaring in this section is because remember, 7 rad 2 squared means 7 rad 2 times 7 rad 2. So it is a multiplication problem. So I would always recommend writing it twice. So I have 7 times 7 are my outside numbers, which is 49. Inside numbers stay inside a radical. 2 times 2 is 4, okay? Again, I stop and look before I box it up. I look to see if I can simplify the rad. Now you'll notice rad 4 is the very first number on my list. That means it's a perfect square. The square root of 4 is exactly equal to 2. So what I end up with is 49 times 2, okay, which is 98, and that's my final answer. 98 is my final answer. No rad left in that problem, okay? All right, now what might also come up with multiplying, okay, are variables, okay? So variables do come up here, okay? So again, we just have to remember some rules. So this goes back to remembering laws of exponents. When you're multiplying, so here again, I'm gonna multiply insides with insides. So what you have to remember is that when you multiply with exponents, the rule is you add the exponents. So here, a rad times a rad is another rad. Okay, x to the 5th times x to the 3rd is going to be x to the 5 plus 3. So we are doing 5. Remember, we add exponents when we multiply. So that's x to the 8th, right? So the multiplying part is done. Then we move on to the simplifying part. Now remember, going back again, simplifying with variables. Okay, the first thing you want to do is look and see, is your exponent even? If your exponent is even, you just got one thing to do, and all that means it's perfect. That means there's no leftover. All you have to do is cut it in half, and you get x to the 4th, no longer in a rad, donezo. Okay? Here, okay, I have x to the 4th times x to the 7th. So again, a rad times a rad stays in a rad. This time I'm doing 4 plus 7 and I get 11. Okay, so that's the in-between answer, x to the 11. Now, again, we have to simplify. So remember, when your exponent is odd, okay, remember the way we simplify it is we break it down into 2 radicals, we drop it down 1 to the even number 10, and we have a leftover x. Anything that's even can be cut in half, so this becomes x to the 5th times rad x. And that's the final answer, okay? So again, if there's something on the outside, you see that 3 and the 4 on the outside, so I am just gonna multiply them to get 12. Now I'm gonna multiply my insides, okay? So again, multiplying, we add exponents. 3 plus 11 is 14. So that's my halfway point. Now I simplify my radical. So when I simplify, I see that it's even, which means it just simplifies to be something that I can cut in half, which is a to the 7. No radical left in that answer, okay? Here, again, you'll notice, again, I have nothing on the outside. So when I multiply, I'm gonna get one big rad. I do have some numbers in front, but again, they're still in the rad, so I'm gonna multiply them, but 3 times 6 is 18. It stays in the rad because they're in the rad to begin with. X times x, remember this is x to the 1 times x to the 1 gives me x to the 2, okay? So now going back to, again, day 1 of radicals. If I have a number and a variable, I'm just gonna look at them separately. The first thing I'm gonna do is look at the variable, because if it's even, I can get rid of it to begin with. So do we see x to the 2nd is even? So I can get that out of there as just an x, okay? So all I'm left with is rad 18. Rad 18 is not on my list, right? So that means I have to simplify it. Rad 18 does break down into 9 and 2. The square root of 9 is 3, right? So I can make the outside 3x, so I could put that 3 with that x, and then bring down my rad 2 for the final answer. Okay, so one more like that. That's probably as complicated as they get. Okay, so here I multiply out again, everything stays inside a rad because it's a rad, and there's nothing on the outside of the rad. 2 times 8 is 16. Add the exponents and I get x to the 7. Okay? So this time the exponent isn't perfect because it's odd, but do you see the number is perfect? So if you see a number that's already on your list, just square root it right away. So the square root of 16 is 4. Okay? Now, gone. X to the 7th. Since it's odd, we break it down into x to the 6th and x. We cut the x to the 6th in half. We get x to the 3rd. And then we are done. Okay, so that's multiplying, right? So again, multiply outsides with outsides, insides with insides, and simplify it if you need to, okay? When we move on to division here, division has the same exact steps as multiplication, okay? Which would be, so again, we divide outsides and insides, okay? Then we simplify if necessary. Okay, so let's start off with some basic ones. So normally division, we usually don't do division with the division symbol. You will usually just write it as a fraction, but remember a fraction bar means division. So in this first example, I'm multiplying dividing a rad times a rad. So remember, both these numbers are inside, so I can divide them. So when I divide them, 20, it stays in a rad, and 20 divided by 5 is 4. Again, you do a check to see if you can simplify, which I can here. The square root of 4 is just 2. So final answer, just 2. Okay, so same thing here. Rad divided by a rad, divide the numbers on the inside and you get rad 20. Okay, but again, you're not done because rad 20 can be broken down into 4 times 5. And we just saw the square root of 4 is 2. So my final answer is 2 rad 5. If you get some numbers on the outside like you do here, same thing as before. You just divide outsides with outsides. So I can divide these two and I get 2. Divide these two, I get 3, but it's rad 3, right? When you divide rads, your answer is a rad. Good thing about that is there's nothing I can do. That is done, okay? So next one, again, divides outsides with outsides and you just get another number outside, in this case 5. Insides with insides stays inside the rad and you get 8, okay? Again, check to see if you can break down that radical, which you can. So I'm gonna bring down the 5. 8 is gonna multiply to be 4 and 2. The square root of 4 is still 2. So what I end up with on the outside is 5 times 2. You don't want to leave that. Just clean it up. Make it a 10. Because they're both outside numbers, we can multiply them now. Okay? So again, variables might come up with this one. So we have to remember, okay, when you're dividing with exponents, what do you do? So if you remember here, so again, I'm still dividing a rad and a rad. So I get another rad. I'm going to get x to a power. I do the complete opposite. With multiplying, we add exponents. So with dividing, we're going to subtract exponents. So here I'm going to do 7 minus 3 to get 4. And then same as before, once the division is done, check to see if you can simplify it. I can. Square root of x to the 4th is x to the 2nd when you cut it in half. Okay, so same thing here. I have a rad with some a's. 10 minus 3 is 7. So my in-between answer is a to the 7. But just like before, since it's odd, we have to break it down. In this case, we're going to drop it down to 6 with a leftover a so that we could square root this. Again, remember, we cut it in half when we square root. So that becomes a to the 3rd, rad a. Anything on the outside gets divided. So here I have a 30 and a 10 on the outside, which divide to be a 3, which would be on the outside. Here I have an x to the 8th divided by an x to the 2nd. And I get, when I subtract exponents, x to the 6th. Since that is even, that means I can square root it without breaking it down at all. So here, cut it in half, and I just get x to the third. And now we'll just join that 3 on the outside. Here, a little bit more to do. There's a lot. So again, I can divide this 4 and the 2 on the outside and get 2. I can divide this x squared and x, right? I can still subtract exponents and I just get x to the 1. But it would be outside because that's outside. But then on the inside, I can divide again these ones because they're insides, right? So I can't divide this x squared by that x squared because one's outside, one's inside. So you can only divide outside stuff with outside stuff, inside stuff with inside stuff. So when you divide, you just get x to the 1. Again, since that's x to the 1, we can't drop it down. X to the 1 is the lowest we can ever get a radical down to, so we are done with that one. Okay? Now this last one has a number and 2 different letters, but again, they're all inside the rad. So if they're all inside the rad, my answer is just going to be one big rad. So I'm going to start with 40 divided by 10 is 4, but it stays in the rad because the 40 and the 10 are in the rad. Now, a to the 4th divided by a to the 4th. Either way you look at it, okay? If you look at it as subtracting exponents, 4 minus 4 is 0. 0 means no a's. Or if you just want to think of it as canceling, aren't these 4 a's going to completely cancel out these 4 a's? Whatever way it is, there's no a's left in our answer, but there will be some b's because this is b to the 3rd. Technically, that's b to the 1. So when you divide, you get b to the 2. Okay? So my in-between answer is the rad, one big rad, 4 and b to the 2. Best part about that is 4 is a perfect square. It's 2. b to the 2nd is a perfect square. Remember, cut the exponent in half and you just get b. Okay, so that's probably as hard as the division is going to get, where it's going to be a combo of numbers and letters. But just like with adding and subtracting, our focus is going to be more on the number ones, less on the letter ones. Okay, but it's still something you do need to know how to do both. Okay.